The truck in this problem has three forces on it, as shown in the picture. In part A, we're asked to find the components of each of those forces. Let's label them tensions 1, 2, and 3, with tension 1 being the 985 Newton force on the right at an angle of 31 degrees, and going counterclockwise, tension 2 with its magnitude and direction, and then tension 3. We need to find the components of each of these tensions. The components of the first one, T1, are shown here, T1x and T1y. T1x is the magnitude of tension 1 times cosine of theta 1. Substituting the values shows that that equals 844 newtons. T1y is T1 sine theta 1. Calculating that gives 507 newtons. For tension 2, the x component is here and the y component is here. The x component is along the negative x-axis, negative T2 sine theta 2. It's sine because it's opposite the angle of 32 degrees. It works out to minus 418 newtons. And the y component, the adjacent side to the angle theta, gets a cosine, and that's 668 newtons. The components of T3 are shown here. They're both negative. The x component is minus T3 cos theta 3, working out to minus 247 newtons. And the y component is minus T3 sine theta 3, which equals minus 328 newtons. So that solves part A, finding the components of each of those forces. Part B asks for the magnitude and direction of the resultant force. The resultant force is just the sum of all the individual forces. They're vectors, so it's the vector sum. The net force is the resultant. We'll first find the components of this resultant force, and that is the sum of the individual components. The x component is shown here. Add all the individual x components to find that it equals 179 newtons. The net y component is the sum of all the individual y components. That's shown here. And it works out to 847 newtons. Now we can take these components and use them to find the magnitude in the direction of the resultant force. That force looks like this, with components in the x and y direction at an angle of theta. Now let me shrink this and move it out of the way so we have room to calculate the magnitude and direction of that resultant. We'll find the magnitude of it using the Pythagorean theorem. The magnitude of the net force is the square root of the sum of the squares of the components. So square the x component, add it to the y component squared, and take the square root. Now substituting all the values and calculating gives a magnitude of 866 newtons. That's the length of that black vector up in the diagram. The angle theta is the inverse tangent of the opposite side, that's the y component, to the adjacent side, that's the x component. So we can substitute values. Calculating to find that the angle theta is 78.1 degrees.